Network security becomes huge, evolving technology in the markets. This has been the other area that was probably the biggest surprise to us. We had seen a lot of projects done with home energy devices. And we said, we don't want to do this just like everybody else has done. We want to open it up so anybody can do it. The standards in the United States did not develop as fast as we thought. And it has been a nightmare trying to have a system where you can allow a wide range of vendors to participate when you don't have standards on how you interface. Regulatory policy, we talked about security and privacy. The distribution loss reductions, load balancing, phase balancing. One of the things that we've seen is that as we increase the amount of renewables on this system, that one renewable doesn't matter if somebody's out there particularly pushed to the outside. Thresholds where we start to see issues are actually lower than we anticipated. So, and what really has been the surprise to us is the impact on the grid occurs before the system arrives at the point where it shifts power back into the grid. So everybody talks about selling power back. That's not from an electrical distribution point of view the problem. The problem is mass demand, where an area has a high penetration of photovoltaics. You have the sun out, so what you're providing is down here. You have a cloud, it pops up. So what we've seen is a significant increase in our load variability. That increase in load variability means we're having to move to increase the intelligence on our substation and our feeders to be able to balance that load. Now, fortunately, because the penetration on the customer side is much slower than we ever anticipated, we think we'll be prepared for it. But we're now having to move to a strategy of value from the in moving out, i.e. building the systems to be able to use it, what we call virtual power plants, upgrading transmission lines, providing a smarter distribution system, upgrading feeders so that as the edge of the system becomes more dynamic, the system itself can respond behind it. So the edge drives the middle, but at this point in time, it's the middle where you've got to invest the money to get ready for that. System efficiency opportunities. Where am I at time-wise since we started just a minute? Okay, I'll be done in just a couple of minutes. System efficiency opportunities. We have seen good opportunities in systems efficiency. The key there is implementing wide amounts of, say, volt bar control or other types of things is inefficient. What you really want to do is you want a system that can spot feeder loading and so forth, and then apply selectively if you're trying to optimize your dollars and investments. In terms of changing processes and budgets, this has actually been a very big deal for us. So for example, we can now run diagnostics at the customer site through our call center when somebody calls in and see that we don't have to send a person out. Well, that makes the call handling times go up. That increases their budget, but we save a lot of money over here. Logical is you split it, but it's still two separate budgets, so you have to rationalize those things and change processes. When we look at some of the customer-facing challenges, many people equate smart meters with a smarter grid. And the answer is it's a component, but it's only a component. Right now we had in our discussions on privacy the fact that our current generation actually bubbles up data. Is that sufficient? Do we need real time? Well, as the grid moves forward, we see the meters become incorporated more as a portion of our distribution automation function, because we'll look at voltage and so forth. But at the same but is that something that's necessary today? How much are we willing to pay for communications? And there's definitely more to a smarter grid than meters. Changing customer expectations. As the customers go along, they see the new things and they think, aha, I can get this. But as was mentioned, this is the largest and most complex machine in the world, and you're on a journey to make it even larger and more complex. Well, as that comes along, customers' expectations change and then what you can provide. Means of customer interaction. This has been a real area for us. Do we do it through utility-owned portals, third-party portals, in-home devices, everywhere? It has big impacts when you start doing all of that in terms of how you manage that data, how you release it. Support for new pricing and DSM strategies. Clearly you can do that. The in-home energy management devices. If you're going to communicate to a wider range, you need standards. You can create them your own, and maybe in your case you have enough authority to do that. Certainly you do in your case. But in our case, as a utility that responds to FERC and others, it's been a challenge. And then the distributed energy resources, including PV and plug-in hybrid, I commented a minute ago on that. But it's something that we see coming, and the impact is really in that area of grid stability at increased penetrations. The other piece that I would mention, it's not on here, but as I mentioned, we're the largest provider of wind. And one of the things we learned with wind is once we went above 10–15%, we had to have abilities to predict wind. And we're looking at the same thing through solar and so forth, so that we could maintain our grid stability. So when you're implementing and you're now becoming subject to environmental conditions, you need to think about those three things. You need to be thinking about, what am I implementing grid-wise? What am I implementing monitoring-wise that tells me my environmental conditions, whether it's customer demand or the weather, so that you can predict better? And then also, what is it that the customers are going to need in the future and so forth. So just a few things to summarize it. Data highways and data storage will have to be designed to handle much larger volumes. You've got to start doing that up front because it has an impact. Am I going to be building my electrical system such that I'm setting thresholds and triggering and sending back, or am I sending all data back? So how you design that up front has a huge impact on your system and the amount of bandwidth that you need. Existing applications have to be shielded from the higher data volumes or replaced, and things like complex event processing can help that. It's possible, though very difficult, to interface to multiple in-home vendors. If you're moving in that direction, get your standards up front so the people can get the equipment in the market. Otherwise, you pretty much have to choose one vendor. That may or may not be optimal in your environment. Customer relationship management systems. As you're looking downstream, one of the things we had to add was customer relationship management. We had options, and you're focused, for example, on getting the electricity for your 400 million. But as you look out, those customers, say in Bombay, wherever, may have different services that can be offered, and you're going to need to be able to manage that. If you have basically customer information systems, they're going to have to move to customer relationship management systems. The network strategy and standards are foundational to the smart grid development. You've got to think of those up front. And then the last one is there's no one way to create value. So what we found here to prepare for the future, as we mentioned, we're finding in our case in the U.S., value tends to push out. Other cases, it may be at the edge or whatever. But the value components, huge value in a smarter grid, encompassing it, but it is on a situational basis. And that's what I have. Thank you.
Thank you, Randy.